Hello everyone, I am Dr. Sudhan Sharma from School of Computer and Information Science in Indira Gandhi National Open University. And in this session, we are going to discuss about inequalities. This is an introductory session about the inequalities. And in our earlier sessions, we had already discussed about the solution to the quadratic equations, to how to solve the biquadratic equations and the cubic equations. Till the moment, we are only exploring the equalities wherein we are solving the equations because the left hand side is equal to right hand side. But what about the situations when left hand side is not equal to right hand side? May it be greater than equal to, less than, or less than equal to. And these are the real world scenarios and wherein the concept of inequalities come into the picture. So, we will be discussing about inequalities in this session, and the objectives of the today's session are that after this session you will be able to find a solution of a set of linear inequalities and draw its graph on the number line. Apart from this, you will be able to find the solution of compound inequalities and find the solution of a set of inequalities involving absolute value. Now, just begin with, so what are inequalities? Inequalities in general, we are solving the equation. Likewise, we had solved the equations many times that ax plus b is equal to 0, ax square plus bx plus c equal to 0. Now, there is a equality sign, that is, there is a left hand side of the equation and the right hand side of the equation, and was we are just balancing the equation by equating left hand side is equal to right hand side. But what about the situations when there is inequality, and what do we mean by the inequality? That there might be a symbol apart from equal to, there might be greater than or greater than equal to or less than equal to. Then in that cases of time, the equality will be x may be greater than equal to something, say 3 or 4 or whatever. Might it be a constant value or might it be an expression. Then there is a case of inequality, and in real world the inequalities are quite prominent, and we are going to apply this concept of inequalities when we are going to understand the concept of linear programming, which is an optimization technique to solve the real world problems. So, I again would like to remind you that the unit contents are interconnected. The understanding of one unit is applicable onto the understanding of the other unit. So, carefully, you should be very carefully listening to the sessions. You should be very carefully applying the concepts which are given into your self-learning material. So, inequalities arise into the applications as do the normal equations arise. We may have the inequality 3x plus y greater than equal to, say, 2x plus something z something or so whatever. So, you can have the inequality. Likewise, we are having the equations. So, there are general statements you should understand, because mathematics is also a language wherein the symbols are connected with the expressions. And you can transform the mathematics into English understandable format, or you can transform English into the mathematical equivalent. Likewise, over here some examples are given. Say we want to say A is more than B, then we are supposed to write in mathematics A is greater than B. A is less than B, then A is less than B by using the expression of less than, by using the expression of greater than. A is not less than B, that means A is always greater than B, or it may be equal to B. So, greater than equal to will be the expression over used over here. A is not more than B, so that means A is always less than B or equal to B. So, it is less than equal to expression will be there. At the most, A is at most B. At most B, that means A is always less than or equal to B. It is not greater than B. A is at least B. At least B is greater than A. It can either be equal to B or it should be greater than B. So, by using these terms, we are able to draft the unequal equations, inequalities. So, greater than, less than, and all these terms are used for the expression of the inequality. In order to have the better understanding, let's translate some of the following statements given the example over here into the equivalent mathematical expression. Likewise, first is say x is at most 7. So x is at most means it is always less than 7 or greater or equal to 7. So first expression will be x less than equal to 7. Second expression is minus 4 is less than y. So minus 4 is less than y. So this is the mathematical equivalent. 7 more than z is less than 15. So 7 more than z is 7 is to be added to the z value, and 7 more than z is at least 15. So it is bound to be either greater than 15 or equal to 15. So the expression will be 7 plus z greater than equal to 15. On the same lines, twice x is greater than y. So twice x means 2 types of x, greater than y, greater than y. So greater than y. Square root of y, the fifth part is square root of y is at least 7. Square root of y is at least means it should always be greater than 7 or equal to 7. So square root of y is greater than equal to 7. Opposite of z is less than y. So minus of z is less than y. Less than y, so its symbol should be less than. Now, in this session, we are going to extend about our discussion about some of the more complex complexity inequalities. Likewise, over here, there, say 5x minus 3 is greater than 2x plus 7 or whatever. We will be discussing about such type of compound inequalities in our session. So, how to solve an inequality? So, that means by solving an inequality, a linear inequality, linear means the variable has the power of 1. Likewise, over here some of the instances are cited, 2x plus 5 greater than 3 minus 7x. Now, the power of the variable x, that is the exponential value, is 1. So, that is why they are called the linear inequalities. And they, such inequalities contain the linear expression. Likewise, over here this is a linear expression, this is a linear expression. All these are the linear expressions. Now, by solving the linear equalities in one variable, actually we mean to find all the values of the variable for which the inequality becomes true. Likewise, in our earlier sessions, we found the root, and we verify whether this is the root of the equation by substituting the value of the root into that equation itself and checking whether the left hand side is equal to right hand side or not. And if left hand side is equal to right hand side, that means the root satisfy the equation and it is in fact the root of the equation. So, now there are the situations, there are some rules and regulations to solve the inequalities, and in order to solve the inequalities we are supposed to perform some of the operations. Likewise, we are going to perform addition, subtraction, multiplication and division operation. But there are some important observations when we are going to perform such operations. The observations are that when we are performing addition or subtraction, that is to when we are adding or subtracting some number on both sides of an inequality, then the sign of the inequality is not changed. The solution set of the inequality is not going to change. Apart from this, when we are performing multiplication or the division operation by a positive number, there are two cases, by a positive number and a negative number. So, when it is the case of positive number, that is by multiplying or dividing both sides by the same positive number, then there is no change in the solution set. But by negative number, when we are multiplying or divide both sides by the negative number, then we need to reverse the direction of the inequality in order to solve the inequality. What do I mean by that? We are supposed to reverse the direction of the inequality symbol when we are multiplying or divide by a negative number. When in order to solve an inequality, we will understand when we are going to attempt the numericals in the remaining part of this sessions. So, in order to have the better understanding, let's solve the numericals and explore how the inequalities are to be solved, and this will give you a better grasp over the subject and you will be able to understand it in better ways. The first example is solve the inequality x plus 2 by 3 greater than 7 by 2 and graph its solution set. Now, what type of inequality it is? It is a linear inequality because the exponential power of x is 1. Now, x plus 2 by 3 greater than equal to 7 by 2. Now referring to the earlier rules, that is addition subtraction, that means when we are adding or subtracting the same number on both sides of the inequality will not change. So in order to simplify this, we are subtracting or we are adding minus 2 by 3 on the both sides of this inequality. So minus 2 by 3 and 2 by 3 cancels out. So on the left hand side we are only remaining with x, and on the right hand side the 7 by 2 plus minus 2 by 3, on solving this expression you will get 17 by 6. So the inequality says that x should always be greater than equal to 17 by 6. So the solution set is x such that x comprises of all the values which are greater than equal to 17 by 6. That means 17 by 6 up to infinity, all values are inclusive. So that's why there is a line wherein the starting point is 17 by 6 and up to infinity all values are counted. So this is how you are going to graph the solution set of an inequality which is given over here, that is x plus 2 by 3 greater than equal to 7 by 2. I hope you understood how to solve a linear inequality. In this case we had just applied only about the understanding of addition and subtraction. In the subsequent cases we will be taking about the multiplication, division, and also of the negative number, wherein we are supposed to reverse the sign to solve the inequality. What we are supposed to do is to solve the numerical and have the better understanding. Now the next numerical, the next example is solve the inequality 4x less than 28 and graph its solution. Now over here the inequality given to you is 4x plus 28. In order to have just the variable, that is x part onto the left hand side, this is the left hand side of the inequality, this is the right hand side of the inequality, we multiply both sides by 1 by 4. So multiplying both sides by 1 by 4, you will get the expression 1 by 4 into 4x and less than 1 by 4 into 28. So 4 and 4 cancels out. So in the left hand side you are remaining with x, and 4, 7, the 28. So on the right hand side you are getting value 7. So the solution set you can express is x, all values of x such that x values are less than 7. Mind it, that means all the values less than 7 means minus infinity 7, but minus infinity and 7, but 7 is not included. That's why we are having a hollow circle over here. Just remember, in the past question even the sign was greater than equal to, so equality was there, that's why there was a solid circle. In this case we are having less than 7, so that means there is no point of equality at the point 7, so that's why we are having a hollow circle over here. And all the terms up to minus infinity which are less than 7 are considered in the as a solution of this inequality. Apart from this, the second observation is that the braces, the symbol of the braces when both points are included is this, and over here it should be this, and this part should be a curved bracket. Now let's solve one more example. Solve the inequality minus 3x greater than 5 by 6. Now this is an important question because over here we are going to address the understanding which we had discussed, which I had mentioned over here, that the solution set of the inequality will not change if we perform any of the following. And over here when we address that when we are multiplying or dividing by a negative number, both sides of the negative number, then reverse direction of the inequality is required to be performed. So over here minus 3x greater than 5 by 6 is the given inequality. Now we are multiplying both sides by minus of 1 by 3. So you see that the symbol greater than equal to, because we are multiplying both sides by minus 1 by 3, which is a negative number, the symbol is reversed. That is, greater than equal to is transformed to less than equal to. That is, multiplying both sides of minus 3, the direction of the inequality is reversed. Solving, because 3 will cancel out with 3 and minus into minus is plus, so on the left hand side we are remaining only with x. And on the right hand side we will be having the solution as 5 by 18, that is minus 5 by 18. So this is minus 5 by 18. And solution set will turn out to be x such that x is less than equal to minus 5 by 18. So this is the solution set, and that means because it is equal to sign, so again we are supposed to have a solid circle over here, and from minus 5 by 18 till all the values up to minus infinity, all things are taken into consideration. So in order to graph this, we are supposed to make a consideration of the solid filled circle as a point representing minus 5 by 18, and rest all the points are mentioned by the direction of the arrow as minus infinity. So there is a caution, there is an observation that because we are multiplying by a negative number, the direction of the inequality must be reversed. This is an important observation and you are supposed to keep in mind when solving the numericals. Now again let's solve one more question wherein we are supposed to find the solution set of an inequality 7x plus 4 less than 4x plus 16. Now this is the left hand side and this is the right hand side of the given inequality. Now over here till the moment we were having the inequalities wherein the variables were appearing only onto the left hand side, on the right hand side we are just having the constants. Then this inequality, the observation is that both the variable is appearing on both sides, there is left hand side and the right hand side. Just by simplifying, that means say by adding minus 4x onto the both sides of the inequality, which is this given to us, we will be having the expression minus 4x plus 7x plus 4 less than equal to minus 4x plus 4x plus 16. Now this minus 4x and plus 4x will cancel out, as a result of which, and this minus 4x and 7x will resolve to 3x. As a result of which, the solution turns out to be 3x plus 4 less than equal to 16, and which is in the form of the inequality which we had solved in our earlier examples also. Now again over here we are adding a negative number. So just to have the variable x onto the left hand side. Now adding minus 4 onto the left hand side, you will find that 4 will cancel out, and onto the right hand side 16 minus 4, it turns out to be 12. So the new inequality will be 3x less than 12. Now over here we are multiplying both sides by a positive number, so that is plus 1 by 3. So the sign of the inequality is not going to change. So multiplying both sides by 1 by 3, you will find that the sign is same, less than equal to. So on solving it, you will find that x is less than equal to 4. So that means less than equal to. So again now over here it should be a solid line fill part. So 4 because it is included, and all the values of x which are less than 4, so minus infinity to 4. So and 4 should be a solid filled circle over here. So this is how you are going to solve the inequalities. Now again on the same lines of action we can solve some more inequalities. Likewise over here 3 by 5 into x minus 2 less than 5 by 3 into 2 minus x is an inequality which is required to be solved, and we are also required to graph its solution set. Performing the same steps, but over here what we are doing is that simplifying it, taking cross multiplication, you can rewrite this inequality as 3 into 3x minus 2 less than equal to 5 into 5 5 into 2 minus x. So, solving this 5 into 5 is 25 and 25 into 2 is nothing but 50. So, this is the first part. 5 into 5 is 25 and 25 into x is 25x. On the same lines, 3 into 3, that is 9x. So, this is 9x. 3 into 2, that is 3 into 3, 9 into 2 is 18. So, the overall inequality is resolved into a very simplified form, that is 9x minus 18 is less than equal to 50 minus 25x. Now, again rearranging the inequality in the manner which we had discussed earlier also, we are getting that expression 9 plus 25x less than 50 plus 18, that is 34x less than 68. So, as a result of which the x is turning out to be 68 by 34, which is nothing but 2. This is nothing but 2. So, that means the solution set is comprised of all the values which are less than equal to 2. So, that means we are having x such that x is less than equal to 2 is our solution set. So, 2 is because there is a equality sign. So, there is a solid filled circle and all the values up to minus infinity are being considered into the solution set. So, the solution set is minus infinity to 2. Now, we had simply referred about the inequalities wherein the solution set is either moving from a particular value to infinity or from a particular value to minus of infinity. But there are the inequalities wherein the inequality exists only in particular region only. In order to understand such type of inequalities, let's solve an inequality given over here in the example, wherein the inequality is minus 3 is less than 4 minus 7x less than 18, and we are required to graph the solution set. The given inequality is minus 3 less than 4 minus 7 less than 18. So, in order to solve this inequality, firstly we rearrange this inequality in a manner we are taking this as set of 2 inequality. So, rearranging, that means 4 when will taken to the left hand side, and when this 4 is taken to the right hand side, the sign will change. So, the revised version of the inequality will be minus 3 minus 4 less than minus 7x and 18 minus 4. Just by rearranging, so minus 3 minus 4 you are getting the answer minus 7 less than minus 7x and 18 minus 4 is 14. Now, this type of inequalities are referred as compound inequalities. Compound inequalities, because we are simultaneously solving 2 inequalities altogether. So, we divide this compound inequality by minus 7, and because the number by which we are multiplying or dividing, there was a caution that we need to reverse the inequality sign. So, when we are dividing it by minus 7, why we are dividing it by minus 7? To have only the expression x. Instead of minus 7x, we want to have only x. So, we need to divide minus 7x by minus 7. Then only we will be remaining with only expression x. So, performing this division by minus 7, you will get this expression, and mind it, the sign are changed. This is less than, now they are changed to greater than and greater than. So, that means this turns out to be 1 greater than x greater than minus 2, which is written over here in the different form. Likewise, minus 2 is less than x less than 1, which are both are same thing. So, that means the value of x resides in the range minus 2 to 1, and the symbol is less than, not less than equal to. So, both minus 2 and 1 are to be represented by the hollow circle, and the range within which the solution exists is between minus 2 and 1. So, I hope you understood how to solve the compound inequalities, what are in fact compound inequalities, and this is the important observation that whenever you are multiplying or dividing by a negative number, then sign of the inequality is supposed to be reversed. Only just by keeping these simple things and solving, the solutions are quite simple. This is another example wherein we are again going to solve the inequality, and just by solving the expression, you will find that the solution over here is the x is lying in the range minus 12 to 14 by 3, but there is an equality sign over here for the number minus 12. That's why when we are graphing the region, we are having a solid filled circle over here at the point minus 12, and there is no equal to sign for 14 by 3. So, that is why we are having a unfilled circle over here to represent the point 14 by 3. That means 14 by 3 is not included into the solution, whereas minus 12 is included into the solution of the given inequality this. Now, the steps of solution of this inequality are pretty same. We multiplied both sides of this inequality by the value 5, because 5 is in the denominator. So, that is why the result turns out to be minus 2 into 5 less than 4 minus 3x, 8 into 5. Solving, we get 5 into minus 2 is minus 10 and 8 into 5 is 40. Again, rearranging the value of 4, taking 4 into the left hand side, it will be minus 4, taking 4 to the right hand side, it will be minus 4. So, 4 is to be subtracted from the expression which are into the left hand side and to the right hand side also. So, minus 10 minus 4 turns out to be minus 14, and 40 minus 4 is turning out to be 36. Now, minus 3 is to be minus 3 is in order to have just an value x, we need to divide left hand side and right hand side by minus 3. So, that is why the sign of the sign will be changed. So, less than will be changed to greater than, less than equal to which will change to greater than equal to. As a result of which we will be getting the solution minus 12 by minus 12 less than equal to x less than equal to 14 by 3, and we graphed the solution as we had discussed in the beginning. Now, inequalities of the absolute values. In order to understand the inequalities of the absolute values, firstly we need to understand what are absolute values. So, if x is any expression which is belonging to say some real number, then modulus of that, that is the absolute value of x, will be x if x is greater than equal to 0, and will be minus x if x is less than 0. So, that inequalities often occurs in the combination of the absolute values. Likewise, we are having some of the example inequalities shown over here, that is absolute value of x minus 7 is less than 2, or x plus 1 is greater than 2. So, these are the absolute values and the basic definition of absolute value states that absolute value of x is equal to x if x is greater than equal to 0, and minus x if x is less than 0. That means absolute value of x is lying between maximum value of minus x and x. In order to solve how these inequalities, let us solve some numericals, and before that we are supposed to understand some of the properties of the absolute values. The properties of the absolute values are very much discussed into your self-learning materials, and you are supposed to learn these absolute values, the properties. The first property says that the modulus of the negative number is equal to the modulus of the number itself. Modulus of the product of two numbers is equal to the product of the modulus of the two numbers. Similarly, the modulus, that is the absolute value of the division of the two numbers, is equal to the division of the absolute value of the respective two numbers. So there is an important inequality, there is a triangle inequality wherein it is mentioned that modulus of sum of two numbers is less than equal to sum of the modulus of the two numbers. So you just need to remember these inequalities, these properties, and we are going to apply these properties to some of the numericals to solve the inequalities with absolute values. Likewise, over here there is an example wherein the inequality is involving the absolute value 3x minus 4 by 2, and the inequality is modulus, that is absolute value of 3x minus 4 by 2 is less than 5 by 12, and we need to graph the solution set. We use the property that if absolute value of y is less than equal to b, then the value of y lies in between the interval minus b2 plus b. So we are given the inequality 3x minus 4 less than 5 by 12, the absolute value of 3x minus 4 by 2 less than 5 by 12. So that means the value of 3x minus 4 is to lie in between the interval minus 5 by 12 to 5 by 12, recalling this property. Now, as we had solved the properties, the inequalities in the earlier session, similarly applying those steps, we come to the solution that x lies in the interval 9 by 18 and 29 by 18. Because equal to sign is there, so both points are included, as a result of which the solid circles are there, and the inequality lies in the interval from 9 by 18 to 29 by 18. So I hope you understood that by applying this property, this is a very important property, that is modulus of y is less than equal to b, then value of y lies in between the interval minus b and plus b. And the steps of solving the inequalities are same as we have discussed in our past numericals. I hope you understood what inequalities are, how they are relevant into our real life, because the inequalities are prevailing in our real life problems. We are going to apply this concept of the inequalities when we are going to solve the optimization problems through linear programming, which is the last unit of the block number 4 of this course. And I again recommend you to attempt more and more problems given in your self-learning material, and try to solve them on your own. Watch the sessions given over here, solve the numericals which are solved in this session only in parallel. That means while you are watching these sessions, try to solve the numericals in parallel, and then you go to the problems which are given into your self-learning material. Thank you.